So let's see another problem in this series, and let's see question number 3. Now in this question number 3, we have a semicircle uh, which is followed by a rectangle and then a triangle of altitude 60 and base. So let's first find out the dimension. The first geometry is a semicircle of radius 20. This makes the diameter or the entire height of the geometry as 40. And what are the units? Let's take them as meters. So 40 meter is the height, and then this distance is 60, and so this base will be 40 as well. So first thing that we have done is mark the missed dimensions. Now the second thing to do is to define the reference axis. So as always, our reference axis is going to be on the extreme left and at the bottom part of the geometry. This is going to be my x-axis, and this extreme point is going to be my y-axis. So second thing that we are going to check is the axis of symmetricity. Now in this image, we can clearly see if we manage to fold this geometry about this axis. Let me change the color. So this axis, it will have an axis of symmetricity, and the top part is definitely going to coincide with the bottom part. So in this scenario, there is no need to find out the centroid location in y direction, because it is obvious it is going to lie at a point which is exactly at the half of the distance, since we have an axis of symmetricity. So entire height is 40, so I'm going to write y bar is equal to 20 meters. Now we need to find out the centroid position or the centroid of this composite geometry in x direction. So we know the steps. So first let's make a table. So table will have how many geometries are there? We have 3 geometries. Geometry 1 of a semicircle, geometry 2 of a rectangle, and geometry 3 which is a isosceles triangle. So, and let's make the table. So number of rows will be 1 row more than the number of geometries. So number of geometries are 3. So number of rows are going to be 4. So these are our rows. So first column is geometry, and we have only 3 geometries, 1, 2 and 3. Then we have area, and this is meter, so meter square. Then we have xi, and the unit will be meter, and then we have yi, and unit will be meter. So we have made our table, and all we need to do is to fill the vacant spaces. So first let's talk about our first geometry, which is a semicircle. So area of a semicircle is given as, area is pi r square by 2. So pi into radius is 20 into 20 by 2, which is 200 pi. So let's put the value. Area is 200 pi. Area 2 is a rectangle of height 40 meters and length of 80 meters. So area will be 8 length into breadth, so 80 into 40, that is 3200 meters square. And then the area of the triangle. Area of the triangle A3 is, this is A1, is given as half into base into height. Height is given as 60. This is not the base, this is height, and base is this one, 40. So putting the value, half into 40 into 60, so this will give you 1200 meters squares of area. So 1200 is the area of third geometry. Now xi means x1. What is the location of x1? We have seen the formula. For a semicircle, from the flat side, the centroid location is given as 4r by 3 pi. I believe so. 4r by 3 pi. Uh, 4r by 3 pi. Yeah, we are right. So if it is from the flat side and we see that the reference of axis is placed on the curvy side. So from the curvy side, it can be given as r minus 4r by 3 pi. R radius is 20 minus 4 into 20 by 3 pi, and this value will come out to be, let's find out, 20 minus 80 divided by 3 by 11.51. So 11.51. Let's fill the value, 11.51 meters. Then x2 means, what is the direction? X2 will be, let's take this out. Now we are first the location of the centroid of the rectangle within its own geometry with reference to its extreme left axis. So that will be half of the length. So I'll write here 80 by 2, and then plus add the distance between these 2 points. So this point radius was 20, so this distance is also going to be 20. So our distance is half of 80 plus 20, means 40 plus 20 is equal to 60 meters. Right? And then we need to take the third geometry, find the x bar of the third geometry. So let's focus on our third geometry only. So third geometry, we know that the centroid location is 1/3 the height. So x bar is 1/3 the height or length. So 60 in x, 1/3, that is 20. And what is the distance between these 2 points? So 20 plus 80. So I will write here 60 by 3, because the centroid lies, for the triangle, the centroid lies at the 1/3 of the distance, right? And then we have plus 20, and then we have plus 80. So 80 plus 20 plus 20, this means 120 meters. Y bar, for every geometry it will be 20, it will be 20, and it will be 20. That's why our centroid is coming out to be 20. So let's fill the values. We know the formula. X bar is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. And this is so because the areas are being added. Let's fill the values. A1 is 200 pi multiplied by 11.51 plus A2 is 3200 and X2 is 60 plus A3 is 1200 plus 1200 into 120 divided by 200 pi plus 3200 plus 1200. Let's find out the values of this answer. So 200 pi into 11.51 plus 3200 into 60, and then plus 1200 into 120. The numerator comes out to be something 3,43,000, and divided by 200 pi plus 3200 plus 1200. So this position is 68.25 meters. So center of gravity or centroid will be given as 68.25 comma 20, unit is meter. So meter. Let's check for the answer whether my answer is also correct or not. And for the previous problem, the answers are: for x bar 32.22, for y bar 67.77 or 78, and by using the second method also, subtraction, I got the same location. So this gives us, if the values of area or their orientation is not changing, it doesn't matter which method you are going to imply, your answers are going to be the same here. And if your geometry has an axis of symmetricity, you need not to find the direction of that particular location of centroid in that particular direction. You can find it by using the concept of axis of symmetricity. So this was the answer. Verify for yourself whether this answer is same or not. Okay, that's all for this video. See you guys in the next one.